Tip, go ahead and start sharing your screen. Our next presenter is Tip. He graduated from USC in 2012, another one of Dr. Baim's alumni. He is currently the founder and chief operating officer at Integrate, a software development company. He has multiple research projects with the Thai government on software cost estimation guidelines and standards. Over to you. I don't hear you yet, in case you're talking.
Okay, can you hear me?
Yes.
All right, thank you for the introduction, Anandi. And yes, Julie, that was a really great video. So, so my presentation is on using COCOMO tool to help with software intellectual property evaluation. It was one of the well, cost estimation was actually one of the major problems in Thailand, and that kind of branched out into using that to help with software intellectual property evaluation. So so today I'll go over a little bit about how this project got started, and I'll go into more details about the valuation methods, the valuation process, and some of the sample projects that we experimented with. So the initial starting point for this project was actually developing the Thai COCOMO project. I presented this at COCOMO forum back in 2015, I think. The project was initiated by the National Anti-Corruption Commission of Thailand. The objective of building the Thai COCOMO model was to have an explicit way of deriving costs for software. And the main goal is to reduce corruptions and to create a fair business between the government and the private sectors. This was developed along with the Ministry of Information and Communications Technology in Thailand. And the goal was to develop a standard and guidelines for estimating costs. Because prior to this, so the way that the projects were estimating their costs didn't really have a good rationale behind any of the software costs that they had. So that the Thai COCOMO project, we eventually developed the guidelines and the standards for software cost estimation. And this was when Dr. Baim came to be a keynote speaker at the one of the events in Thailand when we launched the guidelines and the standards. So once we developed that model, one of the departments, well, one of the government agencies noticed that it's one of the things that they lack was a method for evaluating software intellectual property, the value of software intellectual property. And the intention for them is that the intellectual property can actually give access to funding and venture capitals. So they want to be able to turn software IPs into assets. And some of the other benefits that you can get out of evaluating software IPs is helps you estimate licensing fees, help with investment decisions, partnership opportunities, and such. So with that, they also we were working with one of the Korean agencies as well, the Korean Technology Finance Corporation, and they were an inspiration for this project to happen. What that the Korean government agency has is they have a department called COTEC, and basically what they do is they do technology appraisal for mainly to support tech startups and innovations. And what they do is they have over 100 PhD experts, and they basically evaluate a lot of software software companies, software products, and put a value to them. So it's based purely on expert judgments. So we were working this with the agency here in Thailand, and we were coming up with a way that we can have technology appraisal, put a value to intellectual property without needing just purely expert judgments. So this is where it was a joint research between us. We started an organization called M&P Consulting. That was between me and Molly, also another one of Dr. Bame's students. And we were working with the Thai Software Industry Promotion Agency and Thammasat University. So our goal is to develop standards and guidelines for estimating or for evaluating the value of software intellectual property. And the goal is to be less dependent on experts as well. So just to talk a little bit about software intellectual property and how we define it. So software intellectual property is something that it's an intangible property. You can't touch it. It's and a software intellectual property is something that relies on specific technologies that we develop, that a company or a product uses. And usually it depends a lot on expert judgment and understanding. And we have very few experts that can actually determine what the types or the value of intellectual property. So that becomes very highly subjective. And because of that, the value for software intellectual property is not very, it's not standardized for financial institutions. So it's not accepted by financial institutions to treat a software intellectual property as an asset. So for us, we define intellectual property to be anything that has either a patent, a petty patent, or copyright. So it's either an invention or a product design that's been protected, an innovation has been protected, or anything that has exclusive rights to copies and distribute. So the purpose of the project is to determine how much these are worth, to actually turn these into assets. So the valuation methods, basically we explore 4 different approaches. Well, actually, there are 4 different approaches that's applicable to identifying the value of a software intellectual property. So the first one is using cost approach. The second is market approach. The third is income approach. And the fourth one is using an options pricing model. And I'll go into details of each of the approaches. So the first one, the cost approach, this is the most straightforward approach because it's calculated based on actual data. So all the costs that happens for developing a piece of software, a piece of product. But the problem is it may not be reflective of the actual IP value because you're only looking at the cost of what you invested. And the assumption is that you need to actually have some substitute products in the market because you need to use those as references. So the cost becomes the value of the intellectual property. The methods for using a cost approach, you can either use a historical cost method or replacement cost method. So for the historical cost method, this is purely very straightforward. You basically look at the total cost of development and some of the opportunity costs. So the problem the problem with this is that, like I said, it doesn't reflect the actual value of the intellectual property, because you're only looking at the cost that you invested in. So if you only spend a very a short period of time developing with very few manpower, the cost is very little. So that's not really reflective of your innovations or the actual intellectual property itself. And a lot of times, a lot of the projects that we looked at, we explored, the actual costs were not recorded properly. And I think this happens to most of the software projects. So with that, the data is not, it's just not very clean data to use to identifying the value. So the other method is to look at replacement cost method. It's basically what is the cost to replace this piece of software or product. And basically you look at the cost, but you also explore what's available in the market to see if it can be replaced. So for example, like Coke and Pepsi, those are some things that you can replace, right? They're substitutes of each other. So that helps determine the value of how much it would cost to actually develop a new product or replace it with something else in the market. Some of the problems with this method is that when you're looking to replace a software, it's a direct replacement. So you're not really taking into consideration some of the outdated functionalities, outdated technologies, and if there's depreciation within the economy. So like, for example, a CD might be a very valuable asset during its time, but once DVD or Blu-ray came out, that CD is already outdated. So those are some of the things that this approach doesn't really take that into consideration. The second approach is a market approach. And it's basically you're looking at all the available the competitors and all the available products in the market. And basically you have to do some market research to see who your competitors are, what their pricings are, and try to actually find the value of those products or the company. So for example, if a company that owns a product is sold to another company, those are the kinds of value that would be applicable to the value of the intellectual property. So this actually creates quite a bit of problem, because first you actually require a valid reference to having an existing product in the market. So if you're if you innovate something very new to the market, it's very hard to find references for. And any of the IP related data, it's usually not publicly available. Like for example, like I said, the value of the company, the product owner. Those are those are the information that's really difficult to find. So the third method is the income approach. And this is the most commonly used method. And we basically look at a discounted financial benefit. The assumption that we put on is that the income generated by the product or by the software product is greater than the investment. And also there's very minimal investment risk. So the two methods that we use for income approach are direct capitalization and discount cash flow, which I'll go into the details. So the direct capitalization, this is very straightforward. It's basically looking at how how much income is generated by that software product or the intellectual property. And you deduct some of the cost that happens along the way. But the assumption is that the revenue generated must be stable. Otherwise, it's really hard to predict the income. So let's say the year that the product is launched, you might generate a lot of revenue, but the traffic might slow down the second year and the third year, and then comes up again on the fourth year. That generates that unstable pattern, makes it difficult to actually put a value on the intellectual property. And it's also not very suitable if the product is only released into the market for a short period of time. So there's a very limited time to evaluate the income that the product is generated. So for direct capitalization, it's easy because you have all the data available, but usually it's not, the data is not very stable because the products are usually very new. So the second approach would be to use discount cash flow. And basically, we're trying to turn cash flow into present value with some discount rates. So I won't go into too much detail about the calculations of this for DCF, but basically we're looking at a 5-year projection of the revenue that the product can generate, and factor in the cost, and we turn that into a net present value. Some of the things to consider with discount cash flow is the design and development costs, the research and development costs, sales and marketing costs, and also the age of the product and the period that the IP will last. So the period that the patent will last or the copyrights will last. And we look at the risk and inflation rates as well. So we take all of these factors into consideration into generating the present value of this of a product. And this is actually the method that we choose to use in our model in calculating the software intellectual property, the value. And the last method is to apply the options pricing model, Black-Scholes options pricing model, into software intellectual property valuation. This is actually mostly used in stock options trading. We take that and we apply it with software. So the 6 variables that you look at are first is the remaining development costs until the product can be commercialized. The average value of anything that's similar to our product, and the time that it will enter into the market, the price sensitivity, the income that it could generate without factoring in any risk, and the patent expiration. So it's almost like buying stocks, right? You look at the risk that comes along with the stock that you're looking that you want to trade, and the time that you're going to buy that stock as well. So this is it's suitable for IPs with long-term investment and something that's very high risk. But the way that for this, it's complicated, and also a lot of the software IPs that we explored did not really fall into these categories. So we don't really use this model that much, but it's one of the options that you can use is the options pricing model. So the valuation process that we developed, first thing is you have to look at the the IP stage that you're in. If you're whether you're still in development phase, or you've completed development but it's not released into the market yet, or it's already in the market, already generating revenue. And in each stage, you would use different different approach to coming up with the value. So like if you're in the development stage, you can use the cost approach, because you can record all the costs that's incurring. If it's already finished but it's not yet released into the market, you can use DCF, discount cash flow, or the options pricing model. And if it's already available in the market, we can use direct capitalization or discount cash flow. So some of the required data that we need to actually evaluate the value of the software intellectual property is, first we need to have the detailed evidence and other details of the software to be evaluated. So the software assets, the patents, the trademarks, the copyrights, and all the costs related to developing that piece of software. And one that's really significant is the time frame that this intellectual property will be protected, because that will determine how much it would be worth. And the business plans and the business plans and the financial plans and projections of how much income it can generate. And if the product is already available in the market, we can also look at the past performance of that product and any other related documents that the software has. So the process is, first we identify the development cost, and this is where the COCOMO 2 model comes in. And once we have the development costs, we look into other related costs like the hardware and tools that you use, all the marketing costs, and any recurring costs that would happen along the way for the lifetime of that product. And then we project the income. And once we get all of that, we calculate the present value. And this is the actual intellectual property value. So the process is basically going from costing, taking into considerations all the business plan, and generating the value out of that. So the development, to identify the development costs, the projects that we experimented with, those were software products that are already available in the market, but they didn't have all the costs properly recorded. So what we did was we reverse engineer that software product using the COCOMO model, and we apply some of the expert judgments as well. So like to help to identify the module complexity, the team's capability. And we actually wrote a technical report on this, on how we use COCOMO model to reverse engineer software costs. And to use that as the main data point to feed into software evaluation. So the COCOMO 2 model that we use in our project is the Thai COCOMO model. And we for the Thai COCOMO model, we basically kind of simplified the scale factors and the cost drivers, and to make it more applicable to the data that we had for Thai projects, and to make it suitable for to make it less complex for people to estimate too. So we combine some of the factors, and we cut out some of the factors. So this is the original model for COCOMO 2, and this is the one that we came up with for for the Thai COCOMO model. We basically took out the personnel capability, and we actually looked at team's capability instead and team experience. Is based on our research, this was easier to identify for Thai projects. And also we added a parameter called security, because we took that out from other factors like reliability, and so we explicitly define a factor called security instead, and we took out other factors that weren't really related yet at this point. So this is the model that we use for Thai projects, and this is the model that we use for when we did the project for software intellectual property valuation as well. So once we get the development costs, the next step is to identify all the hardware, the other related costs like the hardware, tools, marketing costs, recurring costs. And once we have all those costs, we look at the income projections. So we do a 5-year projection of how much income this software product can generate. And so the income, we look at the revenue minus any of the fixed costs and any of the recurring costs that happens along the way. And once we get all of that data, we apply it to a discount cash flow method. So we basically apply we look at the cash flow, which is for this type of product is basically the income that the software piece generates. And we apply a discount rate, a discount factor, and we basically put it into 5 years and see the net present value at the end to see how much this software piece is actually worth. So that's a quick view of the process of how we evaluate the software intellectual property. And from this project, we actually developed a system we call the IP evaluation system. That in that IP evaluation system, we have the COCOMO model built into it as well. And it's basically the system, you basically feed in all the information, like any IP related information, like market research, business plan, income projections, the cost factors, and any other risk factors into, and this will basically, we calculate everything and would spit out the value of the IP. And this is what the system looks like. And basically you enter in all the hardware, software, license related costs, development costs, and also the business plan. It's in another window that I didn't show. And this will eventually summarize the value of the software intellectual property. So with this method, we experimented with some sample projects. So we actually experimented with 3 sample projects. One a very small project, one medium-sized project, and one large project. And we define small, medium, and large to be a small is just a few functions without any system integration or any third-party system connecting to it. A medium size is you integrate with at most one external system and with a medium-sized function. And the large project, we the software product has to integrate with multiple systems externally. And each of the project, well, all the projects that we sample with must have either a registered copyright or patents. And we use DCF approach to identify the value, to calculate the value. So this is actually one of the projects that the large projects that we evaluated. It's an insurance adjuster system. So what we did was, this product was already available in the market, but we talked a lot with the owner of the product, and he didn't have any cost recorded, and he couldn't break down the cost or the effort that he spent by modules of the software piece that was developed. So what we did was we basically reverse engineer his software product, and reverse engineering, we define the functions and the use cases, and we size the system with function points, and then from that we feed it into the COCOMO model to estimate the effort. And from that effort, we have the cost for the software development part, and we take into considerations other related costs like marketing costs and everything, and apply the DCF valuation to it. And this is the result that we got from that project. Sorry, it's in Thai, but but basically we got the cost that happens each year, and the incomes that was generating and projected to generate within the next 5 years. And from that, we calculate using the discounted cash flow. And from this, we got the final value of that software, the present value of that software piece. It comes out to be around $3 million US. And one of the this project that we experimented with was actually a success, because based on this value, the owner of the software actually used this information to get loans and funding from the bank, because he was basically able to use this, all the valuation and the documentation supporting this to claim with the bank that his software asset actually has value. And this is actually one of the biggest problems in Thailand, and I'm sure in other parts of the world as well. A lot of the companies that their product is purely software, they didn't, on their accounting side, that software piece doesn't really have any value. So it's not, they can't really consider that software product as an asset. So this was a good starting point for us, because we were able to turn a software piece into an actual asset that can be used as liability with the bank as well. So in conclusion, we developed a method for evaluating the value for software intellectual property, and the main model for estimating the cost, the development cost, is we use the COCOMO model to apply to estimating all the effort that was spent. And usually applying the COCOMO model, we have to basically reverse engineer the product. And at the end, we were able to actually turn a software intellectual property into a financial asset for the company. So that my presentations, well, hopefully you can see how we can actually turn a software intellectual property into an asset, and the method that we use for putting a value into a software IP. Any questions or comments?
Hey, Tip, it's Brad Clark. I love your
Brad.
presentation. I got a question for you. When
Yes.
you use COCOMO and estimate the effort, what labor rate did you use then to convert that into dollars? Was it one labor rate, or was it a labor rate for each year the software had been operating?
So the labor rate, initially what we use is the Thai government has a published rate for different positions and standards for positions, and so we refer to those rates. So they would have a rate for like a senior project manager, a junior developer, senior analyst. So we use that publicly published rate.
Well, it's very, very convenient, very nice. Now, did that rate
But
change? Does it change every year, or does it usually, it's a fairly
yeah.
constant?
Unfortunately, that rate hasn't really been updated that often. So it doesn't really, I think, well, to me, I think it doesn't really reflect the market value, the market rate. But it's just that something, it was a starting point for us to have something as a reference. But yeah, to me, I don't think it's really reflective of the market rate, especially these days, because the rate for programmers and developers these days are really inflated.
Okay, thank you.
Okay.
No other questions? Okay, last chance. All right, I guess that's it. Well, thank you so much, Tip, for calling in and sharing this. I think it was really relevant for this forum. So we really appreciate you joining and coming back after quite some time.
Thank you.